Hi everybody, this is Dean Hoffman, and today I'm going to do a quick presentation of Mike, which has been called the open source alternative to Harvey and Logora. And today I'm going to take a little bit different angle than most and show that you can run this completely local, all the way up to air gaps if you want to. And real quick, this disclosure or disclaimer before we get started. I am not an attorney, so this is not legal advice. Just want to make sure and put that out there. Let me show you real quick just to demonstrate for sure that we are running offline. So there's no question there. Wi-Fi is off. Network is off. No Bluetooth, no anything. So we are completely offline. If I tried to get to a page right now, let's say Google, there's nothing there. So this is completely isolated. And it's running the Qwen or Qwen or however you pronounce it. I call it Qwen. That's probably wrong, but just the way I'm used to saying it. The 3.5 27 billion parameter model, which is a really good one, actually. I like it even better than their newer one. And you can see here, you've got the option to put in API keys and pull in some frontier models, but I'm going to do this demonstration on a local model so that you can see how that works and the speed and all those sorts of things. I've got the prompts ready to go. I didn't want to worry about typing those in here, so I'm just going to go ahead and jump right in and show you the features real quick. It won't take long. And I will start out, this is kind of your familiar territory here that looks sort of like a ChatGPT interface. And I'm going to go ahead and upload a document. And the one that I have is a homeowner's agreement, and it's been anonymized. And I'll go ahead and put that in, and then I'll put my first prompt in. Where does this declaration explain what happens when an assessment is not paid after delinquency? And I want to have it tell us, to cite it exactly where it is and keep the answer concise. So I'll go ahead and run that. And Qwen is fired up. It's begun working, and you can see it's pretty fast. And it's pulling up the data. It tells you exactly where it is. And you've also got a little pill here that tells you, well, two of them actually, that tells you exactly where you can find this and open the document. So if I click on that pill, it's going to open that homeowner's agreement document, and it's going to take you directly to the site over here. So this is very nice. You can see it. So that's one way to use this, is just simply as a, kind of a ChatGPT style chat box and talk to your documents. And you can see it keeps track of your, your history over here. Probably the more typical way to do this, I would guess, for most would be to use a project to, store all of your relevant documents and everything in the same place. So I've gone ahead and set up a project with the homeowner's agreement, but I'm going to go ahead in the homeowner's agreement project right now, and I will add a document, and I'm going to go ahead and re-add that homeowners association agreement, and I'm going to check it, and then I'm going to chat with it. And I've got another prompt here. We're going to actually this time look for a couple of things. So now the chat box is over here on this side. And this time I'm going to look for a couple of different things instead of just one thing. And go ahead and fire it up and let it run. And you can see there it gets to work pretty doggone quick. On some of these shorter queries, this is actually considerably faster than you would even get up in the cloud. We can see we're still running here. And then we get to the end, and we've got our two different citations, our two different pills. Here's number one, and that takes us to the first site. And then we can click on number two, and that takes us to the second site. So, and now you can sit here and talk to your document. And what's nice here is that this project now is keeping track of the chats that took place only inside of this project. So when you come back here, you're not starting over from scratch again. You've got all of your history, but your history is directly related to this particular project. I want to do a red line next. So if we come back over here and say, well, let me upload the document again. And this time, let's do a red line of this, and we'll tell it to track the changes. Redline this as track changes, and you can see here I've asked it to change a number of different things. Change from 45 days, change from 12% down to 6%, make it a downloadable Word document. I'll go ahead and run that, and boom, right away it's done. And then I can download this, save it, and then we'll open it up here. And I'll just do a quick search. Let's see, one of them was what, 45 days. So I'll go ahead and type in 45 here. And, there you can see you've got the red line. It went through instantly and made the changes that you want. And you could go through and find all of them in there. So we did the search, showed how it can cite and then find those snippets in the documents to show you where they're at. Let me also show you the tabular review here. Tabular review. So, there's a lot of workflows in here that Will Chen, put in here. And so I decided to go ahead and use one of them, which is just for example, the commercial lease review. So you can create these tabular reviews and put your own columns in there, which is what I did here. I put some columns in here and I created a hypothetical document. So we'll go ahead and upload the commercial lease agreement demo. And what you can do then is have it extract the data from the document. So here's kind of a hypothetical, lease document with all the typical sorts of things that you might expect to find in it. So we've uploaded that, and now we want to go ahead and extract this specific data here. So I'm going to click Run, and you can see it running over here, and it's going to go through that document and then extract each one of the relevant points or chosen fields and populate them. And you can see here that this is fairly quick. Of course, it depends on the document size, and I did quite a bit of optimizing, frankly, on the setup here to get it quick, which is one of the things that we're willing to help you out with, is to set up a machine to do this. And then once it's done, you've extracted all the data. So you can look in there, you can see what the values for those are, and also you can export this. And we'll go ahead and export the tabular review. And then you can come back over here, and there it is, and open it up. But here it is. Here's your tabular review, and it pulled out all of the relevant information that you asked for and put it into a tabular format. So this is very nice setup. Once again, congratulations to Will Chen for putting this out. Works really nice, very useful with the workflows in there. You can customize it. The one thing I do want to make clear, some people have asked me, because, I compete in this space, and, some have asked, well, how do you feel about a product like this being out there? And frankly, I think it's great. It serves as kind of at least for what I do, more of I'm going to call it an application layer on top of an engine. Let me just differentiate just a little bit, what it is that's different about what CloseVector does. What we do is much more of an underneath that kind of an engine layer. And I'll just go through these very briefly. CaseSignal is the e-discovery component for CloseVector. CloseVector is kind of like the hardware component. If you're going to set up local air-gapped equipment, if you've ever done it, it is not a simple thing. You can go buy it, but getting it to work right and optimizing it and the speed and the stack and making sure that everything works properly and all the components is not a simple task. And if you're not experienced at that, you definitely want to work with someone if you're going to go down that route. And, you want the ability for that stack to remain updated. And, we even take it a step further in terms of helping you with data diodes. But what CaseSignal is the e-discovery component. So if you can imagine, you're involved in discovery and you get a data dump and it's huge. Maybe it's 5 terabytes, and it's everything but the kitchen sink. It's Excel documents, it's Word documents, you name it, it's in there. So what you need, and what is helpful, is you would like to be able to just have something that ingests all of that data and puts it all in the proper places, chunks it, embeds it, separates it, gives it all of the vector scoring that it needs, and then gives you the ability to basically throw in your summary of the case as you know it, and then send out the agent, I'll call it, into the data to begin accumulating that evidence. Typically, a lot of times e-discovery would be, ask this, ask that, ask this, ask that. We take kind of a different position, which is that, give it the scenario that you're aware of to begin with. And the first run, just let it go out and accumulate all of that various evidence on its own. and then you're going to want to go back and find the other side of that evidence too, because, you don't want to miss something that the other side might bring up, and you don't want to appear unbalanced. And at the same time, you want to keep all of that logged in case there's a question about your discovery method, which I think is going to become a huge issue coming up. It's not going to be enough to say we used AI. It's going to be what AI? Do you have the logs, the audits, the prompts, the answers that you got back? Was the model pinned? And what I mean by pinned is, was it the same? You never know today whether you're using the same version of Claude that you were yesterday. They don't tell you every time they change the formula a bit or the algorithm or the weights a bit. So, when it's local and you're running it, you know exactly what you've got, and you know exactly what changed and when it did. So, and then you want to have that evidence all ingested, and then you want to have it all so that it's got a chain of custody. And you also then want to have it so that it is verified, so that if you get a large e-discovery report with statements and evidence and all that kind of thing, you want to make sure that the AI has not hallucinated that evidence, so that anything that it's pulling up, it goes back to the source and checks to make sure that that evidence exists. And you either want a 100% score, or maybe, you go a little bit looser and say, I'll take anything 90% and up. But in that case, flag it so that I can go look at it myself to see exactly what's there. And then we have ZugZwang, which is a German chess word, which is basically an adversarial engine. So that if you're going to, file a deposition or a case intake, you want to explore or anything, what you want is a very deep adversarial analysis that, basically tears your argument apart on one side and has another side simultaneously building the counter arguments, and then has a judge on top that's monitoring the whole thing, and scoring the rounds, and then even I call it like a Supreme Court judge on top of that, which is judging the judge. These are all local models. If somebody wanted to go out to the web and use frontier models, they could, but the idea is to keep all this analysis internal, because otherwise, it could leak to the other side. This does very extensive adversarial analysis, and the kind of thing I'm going to cherry pick, and I'll make it clear, so this is a disclosure that it's a cherry pick. There was in back testing this, I found a case that took 14 years till it was finally dismissed, and ran it through the engine, and within 2 minutes it surfaced what was ultimately going to be the grounds upon which it was dismissed. Now, was there a little peek ahead in the data? There could have been. It was anonymized, but maybe somewhere in the weights it saw something familiar, so take that with a grain of salt, but that's the idea there. Case engine, on the other hand, this is a public signal ingestion engine which goes out and monitors news sources in mass for potential litigation opportunities, public databases, and that I won't go. This I could make a whole entire hour-long thing on, so I'm not going to get into that in detail. Internal search, you've got your whole firm history, whether you're a small firm or a large firm, every document that you've got electronic, every case that you've ever handled, every client, every lawyer, all of that information is locked up in not a very accessible manner unless, it doesn't have to be, is what I'm saying. We can turn that into an internal intelligence engine, which you can search semantically with human language, normal human language. So, you could ask, a question just like you might somebody else, hey, what was that case about that guy where, the dog bit him? You could type it in just like that and go through all of your documents, maybe look for a specific contract that had been written before, maybe an attorney left and there's a knowledge gap now. So it kind of helps with the tribal knowledge problem. Then we have communication analytics, which again could be a very long discussion, just about deterministic ways to monitor analytics on communications and frequency distributions and different kinds of statistical analysis. And then the evidence pack that you want to produce. I think this is going to be very important in the future. My guess is going to be that e-discovery evidence is going to be challenged in the future. And the other side is going to begin asking all the hard questions. And you want to be able to have that all ready to go. And we do. And also data diodes. One of the things that is possible to set up is to continue using your regular computer like you always do, and then connect this engine via a data diode, which operates in the background. So you just simply shoot it over one way to the back engine to do all of this analysis. And it goes through what's kind of like a turnstile. It can only go one direction. can only go forward, can't come back. So, and then it does it the same way going the other direction. And each one of those, each area on the air-gapped computer is in its own looks box, which is an encrypted area for each individual case. So that, what you want to do is on the main computer, we would, set up a holding area for you that is basically going to do any kind of malware scanning or virus scanning or that sort of thing, and then shoot it over, but it prevents anything from getting pulled back. And that's not a software prevention, that's actually a physics prevention. There is no return path for it to come back. And even when it gets over there, it is put into an area that cannot affect any other area within the environment. And then once the work is done there, it can be specifically then approved via data diode to come back to the main machine, but there's no way to egress for it to come back into the computer again. So when you shoot it back over, it's a one-way path that there's no way to extract any other data out of there. So that is a very high security setup that a lot of financial institutions and other government institutions use. Or you could go one step further and go absolutely air-gapped, where there's not even a data diode, where the transfer is literally just a physical transfer, maybe some kind of a thumb drive or something like that. And if you were really at high security, very sensitive data, you'd want to keep the computer in a locked room, and you'd probably want to have all the potential types of, you wouldn't want any drives on it or anything where even a local, let's say a disgruntled employee or something like that would have access. Each individual attorney could have their own encryption key, which only gives them access to their cases and nobody else's. And then you could have master level keys for the firm owner that could see everything. So you could permission it down, and you don't have any additional seat price per user. And your 50th case costs the same as your first case because you're not paying for tokens. This is all local inference. So, with the exception of Case Engine, which actually does run out on the internet, which is probably should be separated from this view here a little bit for that reason. This is all running on local inference tokens, basically for the cost of electricity. So that went a little longer than I planned, but I just wanted to give you an idea of the difference between what a Mike kind of a product is and what we do. And actually they're complementary, because Mike could be kind of I almost view it as being a potential, let's call it a plug-in to CaseSignal, because all of the deep intelligence that CaseSignal and CloseVector, surface and find could be piped into and routed directly to Mike for the drafting and those sorts of things. It could be one integrated piece. I wanted to show you that. And if you want to talk to us about what we have to offer, please give us a call. If you're interested in having Mike installed and running locally, completely air-gapped, partially air-gapped, give us a shout. We can help set you up with the hardware if you need it, and the proper configurations and the install and all those sort of things. That's it. And once again, let me just end by saying this is not legal advice. Anything I've said here, that if you need to talk to an attorney, that's what you need to do. Thank you very much for your time, and have a great day.